Hello everyone, hope you all are doing well. We are still working on our data processing fundamentals, live coding in Python series. And in this video, we are completing the work which we have started previously, where we have refactored the Python code by adding the various class methods to it. So this code is also in continuation of our Python data processing fundamentals, where we have already created these two classes, DatasetSelector and the DatasetManager. However, the previous lecture was not able to complete the data frame filtering by numeric value as well as the categorical values. So that is what we are covering in this video. So by passing all the previous steps which we have completed in previous video, our focus is just to jumping at the very last section where we are adding both new methods to our dataset manager class, where first we are going to add the filter dataset by value, and in order to make this function work we had to add these four new methods which we have added here. And after the filter dataset by value method is added, then we have added the filter dataset by category. After both filter dataset by value and the category methods are added, the next step was to use the both methods in the main.py, where we are loading various different datasets from different Python libraries. Diamonds and planets are from Seaborn versus Iris is from Scikit-learn, and performing both dataset filtering by value as well as the category, and understanding that both of our methods are working as expected. The very last part of this video covers the reasoning and the thought process behind creating a such class architecture, where we have refactored our code by adding the dataset selector and the dataset manager classes. And so please make sure you do follow the very last part of this video to understand everything we have covered so far in this data processing fundamentals live code in Python series. So remember, these two methods we already have implemented in our data set. Here is the get columns and get column data types. We can actually bring these two methods here. The only difference here is that we need to pass the self, and here it became self.dataframe, self.dataframe. That's all needed. Now you will get the dataset columns, get columns, get column types, column data types. Let's run it. Here are the column and here are the column types. If we change wine, we just call it Iris. This is the Iris dataset. So you can get an idea that how quickly we just brought the same method, and everything what we are adding related to dataset processing, it's all coming out into the dataset manager. These variables, because it's showing that shadow name record limit from outer scope, so we could actually rename them. We just call them, rename the element, we just call them ds limit, and limit type we can also call it ds limit type. So get columns is implemented, get column data types is implemented, length is implemented. So most methods are already implemented. Now our next step is to implement the get dataset by value and category both, and these two methods will be part of our dataset manager. So let's look into the dataset, and the implementation of the first get dataset by value was there. We can take this method, bring into the dataset manager, and that's where we come and paste here. This will be our self. So first we need to validate field name. So we need to check what is the validate field name. Let's take this method, bring here. So validate field name, we definitely need it. So self. So all the columns, self dot get columns. If field name in here return true, otherwise return false. So it will become our self dot field name. Next is validate field type value. Validate field type value. That's the second method we need to implement. We need self here. Validate field type value. Next, numeric field data type. Let's take this, and that will become the property or the variables related with our class. So self.numeric data type. So that will become the self dot. Here, return a true, otherwise return a false. And that method will also going to be self dot and type field value. So field value is going to be pass, and whether this value is validate field type. It must be whatever we want. In this case, it must be numeric because of we are validating the value, which is int float, int 64 or float 64. Next, validate self dot, that is also, and here it will be self dot data frame field. So the field belong to the given data set, and last one is validate condition. Which is the validated parameter. If the parameter which is being used as a condition is supported or not. So we need conditions. Now I know the conditions are these. So they will be part of our class because the class is what is handling them. Self dot correct conditions. Return true, otherwise return false. So all these four conditions which we were performing in the previous code, they all are implemented here. So let's take this one and this one, then the third one, then the fourth one. At this point, one thing you need to understand is that this dataset manager manages the data frame. So if you are trying to apply the get dataset by value, it is going to update the data set. So first let me make it self.data frame. So that's self.data frame here, and there is no return because it updates the data frame itself, which belongs to the class. So the get dataset by value is going to be performed at this point. So what we could do at dataset is diamonds, else if dataset name is iris, else if dataset name is, for example, we can planets. So what we are doing here is that, remember, we have the dataset manager here. So this dataset manager holds this dataset which we have selected. But if we would want to filter the dataset, we do not want to filter our master dataset, which is in the DS manager, dataset manager. So we can actually create a new class object and instantiate it. So we can say ds updated equals dataset manager. And here, when we are trying to manage it, we have to provide the dataset name and the data frame which belongs to that particular dataset. So here we will use the DS manager and the data frame which belongs to DSO data frame, and our dataset name will be dataset name, which is we already. So in that scenario, we have actually created a new class object. So whatever this data frame was, now it's set to this new object. Next, now we could say that ds.updated. So ds.updated. So what is our method? I forgot the name. Get data. So we can call it filter actually. So we are doing filtration here. Dot filter by value, and exact same code which we was related with diamonds. And remember, we do not need the data frame because this data frame is already being set for this object. So if we are applying filter dataset by value, that is being applied to the data frame which is stored here, which is a property of this class object. So if we take the ds updated and we just get the length, for example, so we can say print the dataset length, and here we just use the ds updated. So in the diamonds, caret is okay. In the iris, we need to actually find these parameters correctly. So here we can actually use the sub length CM, and the value here 6, so we can actually use all the values from 5.5. And the planets, we already know the planets, we has this mass and upper. So let's take a quick look what we are doing. So iris our dataset, Scikit-learn is the dataset library, so DatasetManager, DS name, data frame, dataset will be first here, that's the correct call. And here is the iris is dataset, we are coming here. Let's put a breakpoint, run the code. Next, okay. Let's see what the results are. Dataset 1, because of sample, let's add more, 100. Okay, we started 100, then after the filter, we are getting 65 columns here. If you would want to filter one more time on sepal length, now we could actually filter on, for example, sepal width here, and value we have 3.5, just use 3.5, run the code. So first 100, then 70, then 6. So you can get an idea that our code related with filter dataset by value is working. Now let's use the diamonds with SNS, and here the filter is caret to upper, and we started with 100 data, 100 values of 100 dataset length, and is 100 by 100. We are looking for the 2 caret diamonds, and I see that values, none of the values are updated. So let's put all the 1 and above. Let's run this time. We started with 100, now we have 41 records based on 1. If you put 2 here, run it 2 caret and above, only 7 records are here. And what we are printing is here. This is the main data DatasetManager. Master is being printed. That's why these are the 100 rows you are seeing as result. It means our filter dataset by value is validated for multiple datasets from different libraries. Now let's integrate our get dataset by category. Get dataset by category. Back here, self, validate field name, change this, so similar to this method, validate field name. So this should be okay. We do not need this code because that was just for review. So, and we can actually write a method to make it also work. So here we make sure that all the column names which are used for the categorical filtration, they must be string. So we just name this method, define validate columns as string field values, and this was our this. So this is a list, so we are just checking if the having items and field values, and it's going to return true, otherwise return false. And as you could say here, the warning is coming as a validate columns as a string may be static. Reason it's saying it is static because this method is not doing anything related to the class specific values. There is nothing we are doing. So what we could do, this is the all the column must be string. So we could name this field is the valid category field types. So let's call it dot valid category field types, and field types valid category field type is string. Take this and replace this. Now this warning will be gone because now what we are handling is related to the class. So item for item, we can break this here. Okay. So that method, now we can use this self dot, and field values is going to be pass here. Third one is valid field data types. So these are the valid field data types. Let's add it as a class properties. And now we need to take this method and also define it. So here we are just validating the field which we have selected, they must exist. So the field name which is being filtered, we need to make sure that field exists. So we do not need this. Let's take this code and create a new method within the class. Define validate field exist, and we are going to pass the field name, and this will become self dot valid data types, and this will become self dot data frame. So field name is going to be checked with the data frame types. Let column type exist. So column type exists. So we have also added that. So self dot, we need to provide the field name. So these three conditions we were checking. So this will become the third condition. This will second, and this is the first one. And here self dot data frame, and we are saving back to self dot data frame. Now you see that code became just a few lines of code. Otherwise, looking into the older code, it was that big. So that's one good aspect of writing classes, that your code will be very modular and really very concise. So get dataset by category, and here was the category, get dataset by category. So we just call it filter dataset by category, because we are filtering everything. And then in the diamonds, here are the two filtration diamond. Filter dataset by category, and here is the condition 1. Condition 2. Let's check the length, convert this back to 1. So now we are going to, and then make this record as 1000. So we will have more records, and now we are using the diamonds. Run this code. Okay, let's take a look one more time. It started with 1000, then 339, then 21. It means that the filtration started with value first, then category, and then category. That's where, if we would want to add this to iris, we can actually use iris. Before we go iris, let's have a planets one more time. Okay, this is planets, and these two categories were related to planets. So first condition is this, second condition is this, let's run planets now. Started 1000, and then 276. If we need to get, we can actually So after these two filtration, 273, 270. It means between here to here, the 3 more records are filtered. So you can get an idea that our code is working. So now if you see that whatever we have written earlier in dataset, all these functions has been transformed one by one into the classes. It means at this point we do not need any of this older data set. So this is not needed, main previous is not needed. So this is our main data set, all the code we have already integrated here. So this data set is not needed. I will close it. Now in the main, we have two classes. So the best option is to move the classes in their individual file if they are bigger one. Like if they are small, then it's okay. So what we could do, we could create two different classes as a file here. So DatasetSelector.py and DatasetManager.py. So dataset selector code is going to be used here. And we need both here. So that is our dataset selector. Now we need to get dataset manager. So we need to have these two. Dataset manager is here. Now we need to reference them to the main. So from dataset manager, import dataset manager, from dataset selector, import dataset selector. So all the code has been migrated from main to these two files. If we run, dataset manager is not using any of these. Let's run. Perfect. The code is working. So now you can get a very good idea about how we have taken the code which we written earlier and moved all of it into the class design. So before I conclude this video, I just wanted to have a side-by-side comparison between the code before we have implemented the class in our Python code and the after. Initially, we started with main. Here, as you see, that our main function was calling this method process selected dataset, which looks into the particular Python library and loads the dataset. And then once the dataset is loaded, and after that, we were just trying to perform various methods, and everything was done in a monolith fashion. It means we load the data frame. Once the data frame is loaded, we start applying various methods to it, and these methods were written into the dataset previous.py, and all the code was very sequential, written in a way that wherever we would want to call the function, apply on the data frame, and the data frame was being passed in each and every function so that we could apply various filtering method or the just information method on that data frame. After we moved away from this monolith or sequential code design and went to the class architecture, we have moved out our code in two separate pieces. First, the dataset selector, and this class is only responsible to know about various Python libraries where the data sets or the sample data sets are available, and depending on the need, we could read a particular data set, and this dataset selector class job is to return the data frame to us based on the library and the dataset name. And depending on various methods available to the individual library, as you could see, the SNS loads dataset this way, and the output of this method is a data frame, which is a pandas. However, in the Scikit-learn, the output is not the data frame, so we have to convert it. Once the data frame is available, then we use the DatasetManager class. And this manager class is designed to perform the various methods on top of the data frame. So this DatasetManager, it uses a data frame, and the initial property of this class is that when the object is instantiated, the data frame is set, and then various methods are applied to this data frame, and the state of data frame is keep updating. For example, whenever we are making the total number of dataset limit, initially the data frame has 100 rows, but if we applied the dataset limit to 50, then this data frame will become the size 50. Then all the methods which you are going to apply, they will be applying on a data frame of size 50. Next, if you would want to apply the filtration by value or by category, that is also going to be happen at the real time, and this data frame will be updated because all the methods of filtration is keep updating the data frame back into in memory. So the results are appearing in this main.py, where we are first instantiating a selector object which loads up the dataset, return the data frame, and this data frame is passed into the DatasetManager object, as you could see here. And after that, you can apply various methods to the DatasetManager object. That we instantiate a new object called DSUpdated, which takes the DSManager data frame, and all the updates are happening in this DSUpdated object. So that's how we keep the DSManager main object is still intact, which has all the data frame properties loaded by the DatasetSelector. The code which we have covered in this series is available in this DeepWorks GitHub repo, and the folder is developer program. All the videos are listed here, as well as you can visit this Python data processing folder for different part of our code. Each part consists of the complete code depending on whatever we have covered. I try to keep the both code just to make sure that you have reference to where we started and where we completed. So this video concludes the first three part of our data processing fundamentals series, where we have started from scratch writing a data management application in Python while reading the various data sets available in different Python libraries. We are going to continue many more videos on this series, and my objective behind each of these videos is to give you the real information so that you can learn how to create the data processing applications in Python. I hope you have enjoyed the content. I do appreciate your time, and I'm looking forward to seeing you in my next video. Until then, thank you so much.